Good morning. Happy Monday. So today we are going to be doing another lab. This is called the Spring Lab. So on Google Classroom, go to classwork. We are on week 3. This is the Spring Lab. You are going to click and open up the Spring Lab. Again, enter with your name. And this assignment, like before, will be done on Desmos. I'm not going to give you slides because everything is pretty much in the Desmos activity. So grocery store weight scales use springs to accurately determine the weight and price of your produce. We are going to model this by using springs and different masses. Curiosity question. How much longer will this spring be if you hang 300 grams on it? So remember, this is your wild guess. This is whatever you think it will be. So let's say I think the spring will be. Oh, I always click the wrong one. Let's do that. Oops. Yep, okay. Or maybe I should zoom in so it's easier for you guys to see. All right, I think the spring will be blank centimeters long. Let me know what you think it is and then click share with the class. Then I'm going to move on to my next part. Research question. How does the mass hanging from a spring affect the length it will stretch? In the text below, identify the independent variable and the dependent variable. So, 2 ways I can do this. Remember, the word affect breaks up the independent variable and the dependent variable. And if I look at my graph, IV always goes on the x-axis and the dV is always on the y-axis. So my IV is mass, my dV is going to be length. And again, click share with the class, and then we will move forward. Draw a line on the graph to show what you expect the relationship between the length of the spring and the amount of mass hanging will be. So do you think it's going to be linear, quadratic, inverse, horizontal? So those of you who don't remember, let's go back to our posters. So horizontal is the pattern that we learned last week where it's a straight line across. Remember, this line shows that everything stays constant. This is linear. Linear shows that there will be a consistent increase, okay, that is steady. Quadratic shows that there is an increase but at a dramatic rate. And inverse is decreasing, which shows that the information will get essentially cut in half. So whichever line you think it will be, make sure that you explain your thinking. So I claim that as mass increases, the length of the spring will, remember, is it going to increase, decrease, or stay the same? Okay, so put one of those and then tell me why. So because ... And then on here, you are drawing a line. So it's either horizontal, okay, or it can be linear. Okay. Okay. Or do you think it's quadratic? Or is it inverse? So you are picking one of these lines to draw. Don't draw all 4 of these. Draw one, and then make sure you click submit. Okay. Once you click submit, keep pushing forward. So we are going to be using an online simulation to complete this activity or lab because we can't do this in person. So watch as the teacher demonstrates the simulation, which is what I will do right now. So you're gonna click and open this, and it says click on the fourth pictured lab. So I already have this loaded. 1, 2, 3, 4 lab. I'm going to click that. Okay. Set up simulation to take the correct data for you by following before you start. So don't even start the lab yet. Number or A, on the far left, click the red minus sign on the energy graph to close it. So I don't need this, so I'm going to close that. Set the mass slider to 50 grams. Here's the mass slider. I'm going to set it to 50. Okay. Click on the far right. Check the displacement natural length box. Right here, displacement natural length. I want that. Okay. Make sure you have a movable line checked or box checked. So movable line. Awesome. Okay. And then set the damping slider to lots. So this one's a little hidden. It's right here. I'm going to move this all the way to lots. Okay, lots. Now grab the ruler from the tools on the right place and place it under the spring so that it starts at the dashed blue line. Okay, this is the natural length of your spring. So here is my ruler. Here is this blue line. This is the natural length of the spring. Okay, remember that. We have a movable line, which is red, and this is the natural length of the spring. So I need to place my ruler on the blue line. Okay. So that each group collects different data. All right. So if you are at home, you can see that we have different groups. So what this talks about is the spring constant. Here is our spring constant. And as you see, when you change it, it changes the thickness of the spring. So essentially, it changes how hard it is to pull the spring apart. So if you're at home doing this and you don't have a group, go ahead and set it to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5. Let's set it at the 5, which is essentially the middle. Okay, there's my spring constant, and then I can keep moving forward with my life. Drag the 50-gram mass bottom left to the spring and hang it from the bottom of the spring. So I'm going to take this. This is my 50-gram mass. Here is the bottom of the spring. Okay. And then read the length from the ruler in centimeters. So first I'm going to put 50 grams here. Okay. And even though it says grams, it also calculates in kilograms, which the kilograms is where we would be graphing from, and the length is where we'll be graphing from in the end. So read the length from the ruler in centimeters. Enter the mass and length in the table to the right. Read the change in mass at the top left corner and repeat steps 2 to 4. So here is the stretch. Okay. And then the height, it says right here, and then you can measure the distance. So one way you can do that is, do you see how originally it was at 0, and then you place it in, okay, and you can see how far it's changed, and you can do it by also moving to where the spring has changed, and then you can count it. Okay, so once you are done doing that, you can read and you can keep going along, keep going, put in your length. Say my length was, I didn't read it, 2 centimeters, and then so on, so on. Okay, I would want to do like 100, 150, 200, 250. Something along the lines of that so I can see how much the spring actually changes. And then I'll just keep whatever my lanes are, putting it in here. And then, oops. Remember, once you have your data points, you'll see it in here. My data is like that. I'm going to want to zoom in a lot closer. And I will want to play, again, with my slider, trying to figure out which one is the best fit line. Currently for mine, it looks like it's the purple one, but that's inaccurate because it's based off of the fact that I don't have data points yet. So your data points should be changed, and once you have it and you know which line it's going to be, you can get rid of all the lines that it's not, and you can answer the rest of these questions by yourself.